into multiplication with rational exponents. So we're going to still have fractions that are in the exponents, but we're going to be multiplying them today. Okay, there's going to be a couple of ways that we can do these problems. Give me just a second. I need to look for something. Okay, I'm going to kind of make two different points. I'm going to show you one way of doing it whenever you actually have numbers. And then I'm going to show you a different concept when we have same base. So let's go back here. So on this, when you are multiplying, that's what that dot means right there, right? Multiplying bases, the 3 and 27, but the 3 and the 27 have exponents, okay? There's only two ways that we can do this. Either the bases have to be the same, or the exponent has to be the same. Otherwise, you're not going to be able to do it. So in this case, the exponents are the same. And if the exponents are the same, we are going to multiply the bases and keep the exponents for just a minute and then be able to do it. So 3 times 27 is 81. And I was able to do that because I kept the 1/4. And if you remember from N1, 1/4 means the fourth root of 81, which means what times what times what times what is 81? And the answer is going to be 3. Same thing here, the 1/3 and the 1/3. So we're going to do 2 times 4, which is 8, but we're going to keep the 1/3, which means the cube root of 8. And what do you multiply by itself 3 times to be able to get 8? 2. So 2 times 8 is 16, but we keep the 1/4, which means the fourth root of 16, which is 2. If y'all don't remember me how I was getting the 3s and the 2s and stuff like that, then just ask and I will remind you. The 2/5 is the same, so we're going to do 16 times 2, which is 32, and keep the 2 over 5, which is the fifth root of 32. And then we're going to square that answer. The fifth root of 32 is 2. And then I keep the square, which is that. Okay. So the fifth root of 32 is in blue. So that answers the blue 2. But the yellow 2 is staying there because we haven't done anything with it. But 2 squared means 2 times 2, which is 4. 4 would be your answer. 243 times 3 is when I grab my calculator and put it in correctly. I still can't put it in correctly. 243 times 3, 729. 5 over 6 is still there. That's a 6, which means the sixth root of 729. And then we're going to take it to the 5th power. So the sixth root of 725, I assume, is going to be 3. But let's see if I can get that. Yeah. 3 to the 5th. 243. Yeah. Okay. 3 times 75 is 225. That is not a 5. But the negative 1/2 is still here. Now recall from N1, we cannot evaluate a negative exponent. So we are going to put everything over 1. To make that negative 1/2 a positive 1/2. And the square root of 225 is 15. So 1 over 15 would be your answer. Same, 49 times 7. Remember, the only reason I can put the 49 and the 7 together is because the negative 2/3 is the same. So 343 to the negative 2/3 is 1 over the cube root of 343 squared. The cube root of 343 is 7. Then we're going to square it, which is 1 over 49. 343 times 3, I've already done that. 729. The negative 5/6. Okay, now look at this. Give me a second. See this problem? See this problem? I put that there for a reason. I kind of forgot that I did that. So I was starting to work the problem anyway. But I've already done this, and I know that the answer is 243. What's the difference between the top purple problem and the bottom purple problem? Well, the 5/6s are negative. So what that is saying is you're still going to get 243 as an answer, but it's going to be on bottom, and you're going to put a 1 on top. All you do is flip it, make it a fraction, put 1 on top. Okay, now here's the difference. On everything that we've done so far, the exponents have been the same. But what's the same now? The bases. The bases are the same. So on this, well, before we did this problem, the exponents were the same, so we multiplied the bases and kept the exponent. Whenever the bases are the same, we're going to keep the base and we are going to add the exponents, because that's the rule of multiplying. To multiply bases, you add your exponents. So we get this, and then we have r and 3/4 plus 7/4. You can throw that in the calculator, or because they already have common denominators, I can keep the denominator and do 3 plus 7. And then 2 would be 5/2. So that would be your answer. And I'm going to keep on doing it here. U to 7/3. Something different. This is up. So U to the 7/3 plus 4/3. I have no idea why I put this number here, because it's basically, well, no, it's not. Okay. So common denominator is 3, and 7 plus 4 is 11. 11/3 does not reduce, so that's going to be your answer. Y to the 2/7 plus 5/2. You get a I don't know why I put an equal sign there. You get a common denominator of 14. 2 and 7 go into 14. So what would we multiply 7 by to get 14? 2. So you multiply the top by 2 and get 4. What do you multiply 2 by to get 14? 7. So you multiply the top by 7 and get 35. And 4 plus 35 is 39. And 39/4 does not reduce. Negative 5/6 plus 8/3, because the bases were the same. Okay, and the common denominator between 6 and 3 is 6. So the negative 5 is not going to change. What do you multiply 3 by to get 6? 2. So you multiply the top by 2, and 8 times 2 is 16. So 16 minus 5 is 11, and 11 over 6 does not reduce, so that's your answer. 3 over 2 plus 1 over 4 plus 17 over 6. Common denominator between 2, 4, and 6 is 12. What do you multiply 2 by to get 12? 6. So you multiply the top by 6 and get 18. What do you multiply 4 by to get 12? 3. So you multiply the top by 3 and get 3. What do you multiply 6 by to get 12? 2. So you multiply the top by 2 and get 34. 18 plus 3 plus 34 is, I have not a clue, 11, 15, and 5. 55 over 12, that does not reduce. Okay, so that's how you would do it. Again, give me a moment. No share. Where's my calculator? Okay, again, I hope you can see this. I don't know if you can or not. Here, I'll just say that you can't. So I'm gonna do, no, not that one. So on this, let's clear our history. And then quit. So we start new. So let's say that we are doing this problem. So 2 exponent fraction 1 over 4. And then because we're multiplying, we're going to scroll over and do times 8 exponent fraction 1 over 4 and press enter, and you would get to like I got to a while ago. Okay, so that's that one. And then let's try here on this. All you would have to do is 3 over 2 3 over 2, scroll over, plus fraction 1 over 4, because it'd be tragic to not know how to, or, add fractions on your own. 17. If you wanted to do all the work and then use the calculator to check your work, that would be amazing. And it's 55 over 12. Okay, that's it.